So today's topic is about the 2010 AMC 10B problem 16. Okay, so basically we have a square with side length 1 and a circle of radius root 3/3 share the same center. What is the area inside the circle but outside the square? Now, we want to draw the graph first. That's kind of obvious. For every geometry problem, we want to draw the graph, even if it seems really obvious. If you don't draw the graph, you might have any misconceptions, and this will probably result in the wrong answer, because the AMC people who make the questions probably have considered about the answer you get if you don't draw the graph and the question misguides you. So they'll probably have a trick answer in there. So what does my graph look like? I have a square and a circle. They have the same center, so there's something like this. So let me just draw my center. Wait, what is that? Okay, whatever. So the center is something like this, right? And I know that. Now I just want to figure out, is my square completely inside my circle like this? Are the vertices of my square touching my circle? Or is my circle completely inside my square like this? And is my circle externally tangent to my square? So these are a few problems we want to consider. What's the size relationship between the circle and the square? We know that the radius of the circle is root 3/3. So, and we also know that from this part to this part, this is actually root 2/2, because we know the side length here is 1. So if this is 1, then the whole diagonal is going to be root 2. So half of the diagonal is going to be root 2/2. So okay, so we know this is root 2/2. Now root 2/2, it seems quite obvious. I'm not going to explain, but it seems quite obvious that it's larger than root 3/3. Like root 2/2 is larger than root 3/3. Okay then, so we know that for the four corners anyways, because this graph is actually symmetric, for the four corners anyways, the circle, these parts of the square, these part of the square is outside of the circle. So our graph is something like this. So the circle and square are not completely inside one or another, but there's something like this. Like some parts of the square are not in the circle, some parts of the circle are not in the square. So what exactly does our problem want us to find? We want the area that is inside the circle but outside the square. So where's this area? So basically we want all the areas like this. So let me just highlight this. This. We've mentioned that the graph is symmetrical because we have the same center, and as you can see, it's kind of just common sense that it's symmetrical and these areas are the same. You don't have to prove that. So we just want to find the area of one of these, and we can multiply the answer by 4. So let's try to find the area of this bottom section over here. We connect the center to the sides, to where the circle and the side of a square are tangent, or you can say intersect. So we have a triangle, and we also have an arc. So let me just draw this. We have a triangle, we have an arc. We want to find the area of the arc, and also subtract it from the area of the triangle. So how do we find the area of the arc? We want the arc measure here. So what's this? Now we have a good reason to be suspicious that it might be a 60-degree triangle. So like our graph is pretty accurate, right? I mean, it's online, so we can try to guess that it's probably a 60-degree triangle, an equilateral triangle, like all 3 sides are equal. But how do we know this? Firstly, we know that this is an equilateral triangle because, well, these 2 sides are both the radius. They're both root 3/3. Now, if I just drew this radius here again, that is perpendicular to the chord, then my radius bisects the chord. Okay, so how do I actually figure out you can say the height of my triangle? So I want the base and the height. So how do I do this? So notice that we know, so if I call this point here, if I call this point F, or let's say I just call this point A for clarity. So if I call that point A here, then the center O, we can say it's O. OA is actually going to be equal to half of the side length, which is just 1/2. So why is that? Because O is actually the center of the square and the circle. So the square, so what does the center of the square fundamentally mean? It's basically where, so this part is actually equal length from, it's actually equidistant from all sides and all vertices. So we know that it's equidistant from all sides, so OA is actually the distance of O to another side, right? So OA is actually the distance from O to another side. If I drew this line here, OB, OA is going to be equal to OB. Now we know that AB is actually going to be parallel to the side length. And since AB, you can call CD, since ABCD is a rectangle, so let me draw you this rectangle. We know that AB is actually equal to CD, which is just 1. So if AB is equal to 1 and AO plus BO is equal to 1, so it is equal to 1, and AO is equal to BO, AO or OA is equal to 1/2. So this part is equal to 1/2. So, I mean, even if you're drawing a not that accurate graph on paper, it's still worth it to try this method out. So I want to see if my triangle is 30, 60, 90 degrees, because this is really common in some circle problems. So how do I know this, if my triangle is 30, 60, 90 degrees? So notice that OA is going to be the long side, so hopefully your graph is accurate to this degree. We know that OA is the long side. So the OA is the long side. I want to see if 1/2 times 1/2. So I want to know that. So basically, I want to know if how do I say this? So 1/2 divided by √3 is equal to √3/3 divided by 2. I know that the portion on my sides are 1, √3, 2. So the longer leg here, the OA, is going to be this √3 portion. And this shorter side here is going to be 1/2 of √3/3, which is √3/6. So I just want to make sure that 1/2 is that, so the length of OA, which is 1/2, is actually equal to √3/6 times √3. So I can rewrite this equation in a much more simpler manner then. So I just want to figure out √3/6 times √3. If this is 1/2, then this triangle over here is actually 30, 60, 90. It turns out this is 1/2. Because √3 times √3 is 3/6, and this is 1/2. That's equal to OA, so that's just great. We have a 30, 60, 90 triangle. So we have a 30, 60, 90 triangle, so we basically now know that this side here, the base, this side here, the red side, is actually going to be 1/2 of the hypotenuse. So the red side is going to be √3/6. Now √3/6 is actually half the base. So if I want the whole base, I'm going to multiply √3/6 by 2. So this is going to be √3/3. So that this again proves that this triangle here is an equilateral triangle, because all three sides are equal. So if the base of the triangle is √3/6, so the base of this triangle is actually √3/3, and if you multiply it by the height, which is 1/2, because that's OA, you multiply it, so you have 1/2 base times height, so you multiply 1/2 base times height, so you multiply that by another 1/2, you have √3/, so 2 times 2 is 4, 3 times 4 is 12. Now that's the area of my equilateral triangle. I still want the area of my whole arc here. I know that this angle is 60 degrees because, well, my triangle is an equilateral triangle. If this angle is 60 degrees, my arc is gonna be 1/6 of the total area of my circle. Now that's just gonna be simple because I know the area of my circle. The area of my circle is gonna be pi r squared, which is just 1. So pi times to r, the radius is √3/3, right? The radius is √3/3. So if I just square this, then what I get is I have pi over 6 times 3/9. That's equal to pi over 18. So I want to subtract the area of my triangle from the area of my arc to get 1/4 of my final answer. So I have pi over 18 minus √3/12 times 4. If I just simplify this, like by expanding and also simplifying fractions, I have 2 pi over 9 minus √3/3. So this is the answer to my problem. Now let's just see if there's an option up there. So there indeed is, and this is option B. So the answer here is going to be B. So in this problem, the main key point is to draw the graph, and we also have to understand the fact that we want to guess if this is a 30, 60, 90 triangle or not, and we have to prove that it is. We also want to know that this graph is actually symmetric, like basically this portion is equal to this portion, which is equal to this, which is equal to that, because this is actually giving us a really good advantage that we don't have to figure out the area of every single piece of our total answer and fit it together. We can just multiply 4 times the answer, and we only have to figure out the answer once. So thanks for watching.